Okay, in this video, we are going to be going over the toolkit. We are on page 18. This is the start to Unit 3. So we have our tile patterns here, tile patterns that we're going to be looking at, and we are looking at y equals mx plus b. That should look familiar. That's the slope-intercept form for the graph of a linear function. Now, we're going to be looking at it in terms of a tile pattern in y equals mx plus b. So instead of m representing what we call the slope, m is going to represent our rate of change. Okay, so to find the rate of change, or m, on a graph, what you want to do is you want to find the increase or decrease between two consecutive figures. And what that means is essentially between like maybe figure 1 and figure 2, we want to know how much the tile pattern is increasing by or decreasing by. Okay. And now let's look at B. B represents, well, that's typically our y-intercept, but now we're going to talk about it in terms of a figure 0. Okay. And to find figure 0, when we're looking at a tile pattern, we basically want to use the rate of change to backtrack from figure 0. I'm sorry, we're going to backtrack from figure 1 to figure 0. And we'll go over a few examples of what that actually means in just a moment. So here we have a few different tile pattern examples. So if we look at our first tile pattern, I actually practiced counting the dots of these already. So if we actually count out each tile in this figure 1, we will get 7 tiles here. In the next one, we are going to get 10 tiles, and then we're going to get 13. So what we want to know is what is the increase or decrease from one tile pattern to the next. So here we have an increase of 3. 7 plus 3 is 10. And that's remaining consistent here. We can also add 3, and we're getting 13. Okay, so when we're looking for m, or our rate of change, we know that our rate of change is an increase of 3, positive 3. To figure out our b, we want to backtrack from this figure 1. So instead of adding 3 to get from figure 1 to figure 2, we're going to do the opposite of that, and we're going to subtract 3 and imagine there was a term that came before this, or a number of tiles in the pattern that came before that. So 7 minus 3 is going to be 4. So that if I were to start at 4 for the 0th term, then I would go plus 3, plus 3, plus 3 to get to the next ones. So we're going to say 4 is our y-intercept, or our figure 0. We can then write our equation in y equals mx plus b format. Place our m and our b into the equation, make sure we have our x there. And then for the 100th figure, what we want to do is basically y is going to equal 3 multiplied by 100. And then we're going to add 4 to that. That's going to be 300 plus 4. And that will end up being 304 tiles. Okay. And we can also check this with our equation. Like, for example, if I put a 1 in there, 3 times 1 is 3. 3 plus 4 is 7. Good. That worked for figure 1. If I put figure 2 in there, 3 times 2 is 6. 6 plus 4, that gives me 10. I can also plug in 3. 3 times 3, that is 9. And if I add 4 to it, I'm getting 13. So it should really work for any figure number. All right, in our second problem here, let's grab a new color. We've got 1, 2, 3 tiles. And then we've got 1, 2, 3, 4, 5 tiles. And then let's take a guess. 3, 4, 5, 6, 7 tiles. So it looks like our increase here is by 2. Increase here is by 2. So that means our rate of change, or our increase, is a positive 2. And then to backtrack, let's say I wanted figure 0, I'm going to subtract 2. So I'm doing the opposite of that. That means figure 1 would have 1 tile. I'm sorry, figure 0 would have 1 tile. So that would be our figure 0. If we're writing our equation in y equals mx plus b format, we've got y equals mx plus b. And then for our 100th figure, we can say y equals 2 times 100 plus 1. And you should be able to do this for any figure number. Not always going to be the 100th figure number, but we wanted to do something where you wouldn't want to necessarily continue and draw the pattern. You would want to use a formula instead. So now we've got y equals 200 plus 1, and that's going to be 201 tiles. Y is representing our tiles in this case. All right, let's look here on our last one. Let's maybe get green here. We've got 1, 2, 3, 4, 5, 6 tiles. 1, 2, 3, 4, 5, 6, 7, 8, 9 tiles. And I'm going to take a guess that there's 12 tiles in this one. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You might also want to see the pattern of where it's actually increasing in the figure. So if you notice here, I'm going to highlight these tiles in just a little bit. And then if I highlight, this is the same figure in the next one, but the 3 that are being added, there's kind of 1 here on the top left, and then there's 2 here on the bottom right. And then you'll notice from this figure to the next figure, there's 1 more being added here, and then there's another being added, or 2 more being added here. I'll take that off though, so that doesn't distract you. All right, so now we've got an increase of 3. We didn't mean to give an example of the same type of increase, but at least our starting value is not going to be the same, because if we subtract 3 from our first figure, because we want to backtrack to our figure 0, we'll get 6 minus 3, which is 3. So for this one, we've got a rate of change of 3. We also have a slope-intercept of 3. So when writing our equation, it'll be y equals 3x plus 3. For our 100th figure, we would then say y equals 3. We'll multiply that by 100, and then we'll add 3 to that. So that will be 300 plus 3, which is 303 tiles.